Welcome to The Explainer. Today, we're diving into something big: how China is essentially building its own complete AI ecosystem right from the silicon up.
And this isn't just a story about some shiny new piece of tech. What we're really talking about here is a fundamental shift in the global balance of power when it comes to AI.
Think of it like building a skyscraper. You've got the silicon chips. That's the bedrock foundation. And then you have the intelligent software. That's the incredible structure being built right on top of it. You can't understand the whole story without looking at both. All right, so let's get into it, starting with the hardware, the chips. The question is, why is it so incredibly important to build your own?
Well, the answer really boils down to two things: intense competition and the geopolitical chess game that's completely reshaping the tech industry.
You see, all this geopolitical pressure has basically forced China's hand. It's lit a fire under their own chip development. Because of these restrictions, huge Chinese tech companies are now pretty much required to buy domestic hardware. And just like that, what was a huge challenge becomes a massive built-in market opportunity.
And right on cue, a new player has entered the game. It's a homegrown chip called Ghana. It's a TPU, that's a tensor processing unit, and it's designed to do one thing: fill that exact gap. Now, this isn't just about making a good enough replacement. Oh no. The company behind it, Tech, is making a really bold claim. They're saying their Ghana TPU can deliver up to 1.5 times the performance of NVIDIA's A100, which is, the gold standard. And it supposedly does it all while using less power. I mean, that is a huge claim. So what makes you even listen to a claim like that? Well, it's the team. These aren't just some random engineers. The founder is a veteran straight from Google's own TPU team. We're talking about real industry insiders who know this stuff inside and out. They know exactly what it takes to build this kind of high-performance chip. Okay, so that's the foundation, the hardware. Now, let's look at the other side of the coin and see what kind of incredible software you can build on top of something like this. And that brings us to a new model called GLM-4.6V. It was just released, and honestly, it's showing off some pretty remarkable skills.
So it actually comes in two flavors. You've got the Big Brother, a massive 106 billion parameter model for big enterprise stuff. But then you also have this smaller, nimble Flash model. It's open source, and you can actually run it on a single powerful GPU. So you get both maximum power and maximum accessibility in one package. It's pretty clever. But here's the really wild part. Even with that huge difference in size, both of these models, the big one and the small one, share the exact same absolutely enormous 128,000 token context window. So what does that number even mean in the real world? It means the model can chew through a massive amount of info all at once. We're talking like 150 pages of a PDF or a full hour-long video, and it won't forget what was at the start by the time it gets to the end. That's a huge deal.
Okay, but specs on a page are one thing. Seeing what this thing can actually do is something else entirely. So, let's check it out.
All right, first up, a pretty simple visual test. We've got this image of traffic lanes, and the model is asked a really straightforward question. And boom, the answer is perfect. But look closer. It's not just saying the right lane. It's actually reading and interpreting the signals it sees. The red lights, it sees the green arrow, and it understands what those symbols mean for traffic. That's a much deeper level of reasoning. Okay, let's up the difficulty. How about deciphering this? A super messy, handwritten note, complete with crossed-out words and all. And look at this. It not only transcribes the text, but it's smart enough to ignore the parts that were crossed out. And then it goes a step further and correctly identifies the whole thing as a handwritten love note, picking up on the sentiment. That's not just reading, that's understanding. All right, last test. Let's see how it handles video. Here's an AI-generated clip, and the task is simple. Describe this video. And the response is just brilliant. It really shows off what this model can do. It doesn't just say a woman and a dog. It picks up on these tiny, subtle details, like the fact she's sitting on a bench or that the dog is a golden retriever. That level of detail shows some serious visual comprehension.
So, let's recap. We've got a powerful, new homegrown chip, and we've got a remarkably capable new AI model. The real question is, what does it all mean when you put these two things together?
And this, right here, is the biggest takeaway. These are not isolated events. They're two halves of a whole. What we're witnessing is the deliberate, piece-by-piece construction of a completely self-reliant AI ecosystem, from the actual silicon all the way up to the smart software that runs on it.
So why does this matter so much? Well, for one, it's a way around all those international chip restrictions. It proves that you can build your own top-tier AI stack. It's a huge move from being dependent on others to being technologically sovereign. And what's really fascinating is that it's not just about China versus the world. It's creating this intense competition inside China, which is just pushing innovation to happen even faster.
And that really leaves us with a big question to think about. Maybe the global tech race isn't one single sprint to a finish line anymore. Maybe it's becoming something different, more like a series of parallel marathons where different, powerful, independent ecosystems are all running their own race on their own terms.